Yes, class. Am I audible now? Is it audible?
Yes, ma'am.
Okay. So capacitance we had started in the last class, and we have to continue from this only. I have told you that capacitance, it's the ability to store charges, and the device which does that, we call it as a capacitor. So parallel plate capacitor, let's come to that. C is equal to Q by V is important from here. Okay, so parallel plate capacitor, some steps we had seen in the last class. One case we have done. This was the first case which we have done. No modifications in this we have seen. So in this case, we had seen that if two parallel plates are present, in between them air is filled, then what are the steps? How to calculate the derivation or how to perform the derivation? Calculate the resultant electric field, substitute the value of the surface charge density, calculate potential using the value of electric field. Fine. So once you have the value of potential, put it in the formula of C is equal to Q by V, and finally we'll get the value of C. You have to remember this formula, capacitance is equal to epsilon naught A by D. This formula you all have to remember. Now completely filled dielectric medium, I have told you, we use this formula and multiply it with K. Now let's come to one more case where we have parallel plate capacitor filled with a glass slab. Now what we are doing, these two plates are present, class. Look, these two plates are present. Now when air was filled in between them, we had seen that the formula was C is equal to epsilon naught A by D. Now what we are doing, a dielectric slab whose thickness is T. T is the thickness of the slab. We have brought in between. Total separation between the plates is still D. Thickness of the slab is small t. So electric field in the dielectric region is something else. It is ED. And electric field outside is E naught, just to represent. Because now this leftover space, this leftover space is air. So we know that this is air now. So this is a slab which is filled. Now electric field due to the air would be something else. Sigma by epsilon naught, remember? We have seen in the last class also. But when we are talking about the dielectric slab, the electric field which is present within this dielectric slab, it won't be just sigma by epsilon naught. No. Remember, we multiply a K. When the dielectric constant is K, you see here the dielectric constant is K, that is given also. We have taken K. So this becomes K epsilon naught. Now what is the total electric field? Sigma by epsilon naught plus sigma by K epsilon naught. Now when we are calculating the potential difference, so here you will see the difference by yourself. Firstly, electric field. Now class, you please be attentive and answer. You know, we have seen in the last class, for calculation of potential, we use this formula. Potential is equal to electric field multiplied by the distance, right? Electric field multiplied by this distance. Now you tell me, when we are calculating the potential due to air, or let's say due to this dielectric slab, what is the length that I should multiply? Anyone from the class? Just the slab part. Electric field is ED. What is the length of the slab?
E.
T. Very good. So we should multiply T here plus electric field due to air. Now everybody please answer this in the chat column. What should I multiply here? Please all of you answer in the chat column quickly. What should I multiply for E naught? What is the thickness of E naught left? Yes, class, answer. Otherwise, I'll call your names then for answering. At least try once, whatever answers you're getting. Yes, Zaina, very good. D minus T. See, we just need this space and this space because this space is already occupied by T. If total is D, and in between T has been occupied. So we will say D minus T is only left, right? So this is D minus T. This is the difference that would come in this derivation. Same steps we are following. Now let us put the values of these electric fields, right? So one more thing also. Here we'll have Q is equal to sigma into area. So potential would be, what is ED? ED is sigma. Sigma is Q by A. No, we are not substituting the value of charge. We are substituting the value of sigma. Sigma is Q by A. So what is electric field? Sigma by K epsilon naught. Sigma is Q by A. So Q by K times epsilon. Clear, class? I'll tell you this again. Wait. See, potential is electric field into the thickness. Electric field we are calculating. Electric field for air is sigma by, not for air, for this dielectric slab is K into epsilon naught here. Sigma, you know, it is charge divided by the area. So this will be substituted as Q by A. Sigma has been substituted and this left over K epsilon naught. So now it's clear, Q by A K epsilon naught. Similarly, we will write now this same thing for the electric field due to air which is left. Plus this multiplied to T E naught. This is sigma, which is Q by A. Sigma divided by epsilon naught. Multiplied to the separation D minus T. So we have the potential now. These were the steps. Now C is equal to Q by V. Q by V. Let us write down the value of V. Let's do one thing, class. Let's take this Q by A epsilon naught common. So what are we left with from here? T by K, right? From here, plus D minus T. Okay, class. Q gets cancelled. This A by epsilon naught goes up. Look what is our formula now. A epsilon naught has gone up. So A epsilon naught is up. What are we left with? D minus T and this plus T by K. That's it. This is the formula. If a glass, if a dielectric slab is inserted with the thickness T, what are all the terms here? Let us revise it. C is the capacitance, which we are calculating. A is the area of the plates. Epsilon naught is the constant, 8.85 into 10 to the power minus 12. T is the thickness of the slab. K is the dielectric constant. And D is the separation between the plates. Separation between the plates. One more case is left, partially one, this next one. But first you write down this, understand this, revise it. Any doubts if you have, get it clarified, then I'll discuss the next derivation. Please write it, class. You have physics exam on Sunday, means on 9th of June, chapter 1, 2, 3, 4. Okay, for the third and the fourth chapter, let me see, because see, this week your second chapter would be over by Thursday. So for 3 and 4, let me arrange extra classes for you, Mariam. Done, class?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, class, the same case, partially filled slab only. But this time, this is not a dielectric. Dielectric, I have told you, no, dielectric means something which is insulator. Okay. Now we are having a conductor, complete conductor. Now, what the difference will arise here? See, class, in the first chapter only, I have told you, when we were studying that sphere was present, and even in the equipotential surface class which I had taken, inside the conductor, no charge goes. Remember, I have told you all the charges which are present, they are present on the surface of the conductor only. So if no charge is present here, then we do not have any electric field present. So simply electric field is zero inside a conductor. That's why we will be taking directly electric field. So this is easier than the previous part. In the previous part, we had lots of questions from the slab part. Now it's simply electric field from this conductor, it is zero. Though the thickness is T, separation is D, sigma, Q, A, everything is remaining the same. This part is again air. So E naught will be the same. Sigma by epsilon naught, which is Q by A epsilon naught. Now when we are talking about potential, electric field would be the same. E naught D minus T. But when we are talking about EC conductor, this EC multiplied to T, this term will directly be 0. So we'll have a very quick answer here. This is Q by A epsilon naught and D minus T. C is equal to Q by V. Q by V. So when you substitute in the value, Q by V, Q D minus T, A by epsilon naught will go up. This cancels. C is equal to A epsilon naught by D minus T. This is the part. What all four things we have studied? Let us quickly revise it. See, four cases we have seen. When completely filled air, when this dielectric slab was present and it was completely filled with air, nothing, no other material was present in between. Here, in this case, this was completely filled with air. We had the formula epsilon naught A by T. When this was filled with a material of dielectric constant K, formula was K times epsilon naught A by D. When a dielectric slab was partially filling it, this was the dielectric slab which was partially filling it. The formula was C is equal to epsilon naught A by D minus T plus T by K. And then finally, a partially thickened conductor was placed here. Then we are getting epsilon naught A by D minus T. So these four formulas are completely important. 1, 2, 3, 4. Please remember them. I'll be now discussing questions with you. First, write down this part. Done?
Yes, ma'am.
Yes, ma'am.
Before you start with this question, class, just one thing. I have written all the four formula. Read it, draw the rough figure, and then tell me, all of you, according to you, which of these formula should be used. At least tell this much part. See, this says that a parallel plate capacitor with plate area 10 centimeter square and a separation 5 millimeters. Yes, so Yahya and Zaina, they have given the correct answer. It would be option 3 only. See how? It is saying a dielectric slab is there. Now the difference, how do we know which case is this? Area of the plate is 10 centimeter square. The area of the plate is 10 centimeter square, which is 10 into 10 to the power minus 4 meter square. Separation between the plates is 5 millimeters, means D, this is 5 millimeters. D is 5 millimeters, which is equal to 5 into 10 to the power minus 3 meters. Then it is saying thickness is 3 millimeters of the slab. It means definitely it is less than this. Then only this can be 3 millimeters. So thickness is 3 millimeters. 3 into 10 to the power minus 3 meters. Fine. Now, definitely this is the case of the third. First, it is not possible because something is present in between. It is not complete. See, this is the partial case. So these two first are completely eradicated from here, but two are left. We have to eliminate one from these. If this was a conductor, we would have used this, but this is a dielectric slab where the value of dielectric constant is also given, K is equal to 2. So this is the third part. So which formula we'll be using? We'll use C is equal to epsilon naught A divided by D minus T plus T by K. This formula only we'll be using. So for the first part, capacitance, epsilon, this is 8.85 into 10 to the power minus 12. Just a second. Area was 10 into 10 to the power minus 4 divided by D is 5 millimeters. 10 to the power minus 3 minus, this is 3 millimeters plus 3 millimeters by 2. Whatever answer you will get, you can calculate it from here. For the second part, voltage is given as 100 volt. So you can calculate the charge by Q is equal to CV. Third part is energy. Energy we have not discussed, no? Let's discuss energy. Do one thing, write down these two parts first, then we'll let us discuss energy then. See class, energy stored in a capacitor. So you have parallel plate capacitor. Now see, Q is the total charge on the capacitor and V is the potential of this capacitor. Now we are calculating the work done. That is the potential energy by the cell. So basically what are we saying? That from 0 to this Q value, the charge goes up. All right. And V dash is the small amount of potential which is changing. Now look here, when we are calculating, when we are integrating it, we have to integrate to find out the total work done, right? dq by V. V dash is what? V dash is Q by C. Q is the small amount of charge. So small amount of potential would be small amount of charge by capacitance. So this becomes Q by C dq, integrating it from 0 to Q. Now see, from here 1 by C, this is common. Q dq Q dq we have to integrate from 0 to capital Q. So this is like Q to the power 1. So we'll add 1 to the power divided by 1 plus 1. So what we'll get? Q square by 2. So this is equal to Q square by 2. C is also present from 0 to Q. This becomes 1 by 2. C is common. This is Q square minus 0 square. So finally, you will have the formula of the change in potential energy as Q square by 2C. Now what you can do, because this is the work done, Q is equal to CV, you know. So what we can do, U is equal to half. We can put the value of Q square, C square, V square divided by C. This gets cancelled. So U is equal to half CV square. If you have only capacitance and only potential, you can use this formula. If you have only charge and capacitance, you can use this formula. So this is the first. This is the second. Just in case if you just have the potential and charge, then so what you can do, C is equal to Q by V. So you can use half. This is half C. So we can write this as C square V square we had. So this becomes Q square V by Q. So 1 Q cancelled. Q is equal to half Q V. This is the third formula. So in this question, which we were discussing, last part would simply be U is equal to half CV square. You can calculate it from here. First, write down this. Then I'll show you the derivation for energy.
Ma'am, what do we use as SI unit in the
Joules,
third case?
energy. So joules. See class, now spherical capacitor. So parallel plate capacitors are over. I have told you, cylindrical capacitors are not part of your CBSE syllabus. So you just have spherical capacitors which are present. So spherical capacitor, just for the formula and derivation part we'll be doing, because that's not very important from your examination perspective. So you have two spheres. This is the first sphere, this is the second. So two concentric spheres we have taken. First radius is R1, second radius is R2. Plus Q is the charge here, minus Q is the charge. Why minus Q? Because of induction. This has induced it. Now R2 is greater than R1 shows that sphere 2 is bigger. Now potential due to the first one would be KQ by R1. Potential due to the second one would be minus KQ by R2. Fine. So this would be the formula of the capacitor that we have to use. Now, when we are talking, we can take KQ common and we'll be left with 1 by R1 minus 1 by R2. Right. Now, this is the value of potential. Let us put it in the formula. C is equal to Q by V. So, this will be Q by V. KQ by 1 by R1 minus 1 by R2. Charge cancel. And when this K goes up, we can write, oh, okay, without going up, let's just keep it as it is. What is current formula obtained? K is 1 over 4 pi epsilon naught. So 1 over 4 pi epsilon naught. This is 1 by K here, divided by, let's take the LCM here. This becomes R1 into R2 and R2 minus R1. Fine. So this term will go up, this denominator part, and the formula that we'll have would be 4 pi epsilon naught R1 into R2 divided by R2 minus R1. That's all you have to remember for the spherical capacitor. Even if a numerical it would be just a formula based questions. Let us see two more questions which are actually derivations in the form of questions. First, write down this part, spherical capacitor. See class, we have to calculate the force between the two plates of a capacitor. So the first plate is completely charged with the positive and the second is charged with the negative charges. Now electric field's direction will be away from the positive towards the negative. So this direction will be valid. And what is the electric field due to the plate? Due to two plates, it would be sigma by 2 epsilon naught. Right? Sigma by epsilon naught plus sigma by epsilon naught. That would be sigma by 2 epsilon naught. For the single plate we are writing. Remember, when we used to write for the two plates, sigma by epsilon naught, 2 epsilon naught plus sigma by 2 epsilon naught. Then we used to write this as 2 sigma by 2 epsilon naught, and then we had sigma by epsilon naught. Just a Now we just have a single plate electric field due to this positive plate I'm writing. And sigma also we have seen it is charge divided by area. Electric field would be charge by area to epsilon naught. Now you know force is minus QE because of this negative plate. We are writing force on this negative plate. So force would be minus Q multiplied to this electric field. This electric field is Q by A to epsilon naught. So what would be the formula of force? Minus Q square by 2A epsilon naught. Now class, this is a derivation which we have done in the form of question. One more derivation we'll see in the form of question. First write down this. Yes, class. Now we have to calculate the energy density between the capacitors. Now energy density simply means energy per unit volume. So we have calculated energy. Energy was half Q square by C. Now, when we are talking about volume, volume is always area multiplied to thickness. So let us divide these two. When we are calculating the energy density, energy, which is Q square by 2C divided by volume. Fine, class. Now let us put the value of capacitance also, which we have studied. Epsilon naught A by D. So we'll have Q square by 2. C is epsilon naught A. D will go up. And here we have AD. So D will be cancelled. We'll be left with Q square by 2 epsilon naught A square. Class, see one thing. Look here. Look at this. Sigma is equal to Q by A. So sigma square would be Q square by A square. So I can replace this entire term with sigma square, sorry. So finally, this will become sigma square by 2 epsilon naught. Let me just multiply and divide it by epsilon. So what I'll have sigma square epsilon naught divided by 2 epsilon naught square, right? Now class, look again one thing. Look here. Before this, see, sigma square by epsilon naught square is what? Sigma was electric field was sigma by epsilon naught. So sigma square by epsilon naught square will be electric field square. So we have the final formula as half, because of this 2, epsilon naught multiplied to E square, and E is the electric field. Fine, E is the electric field. So what is our final formula? Half E square into epsilon naught, where our E is the electric field between the plates, which is sigma by epsilon naught. And one very important conclusion, that energy density is directly proportional to square of electric field or directly proportional to the electric field. So if electric field increases, the energy density also increases. Tell me class, this is clear? Again, we have done it in the form of question, but please, this can come as a derivation also. Clear class? All of you?
Ma'am, I have a doubt.
Yes, yeah, say.
Why are we multiplying and dividing it by epsilon naught?
So as to get the relation in terms of electric field. Because here, this formula is also valid, sigma square by 2 epsilon naught. If you have sigma, you can use it till here. But what if the question comes in terms of electric field? And to see the relationship between the electric field. That's why. Okay.
Okay, ma'am. Thank you.
Write it, all of you. All right, class. So if you've completed, you can leave. Now we'll complete this portion, sharing of capacitors, on Thursday now. Okay, class. Thank you so much.
Okay, ma'am. Thank you, ma'am.